everyone, welcome back. My name is Siddharth Nawani and today we would be discussing happy numbers. So I am quickly going to read through the question. You can pause your video and read or go through the question again. So the question says write an algorithm to determine if a number n is happy. So what the question is trying to say is a number is happy if, so suppose the input number is 19. We do the sum of square of the digits. So 19 we can break it down into 1 and 9. 1 square plus 9 square is equal to 82, right? Again, we will break down the digits into 8 and 2 and square them up. Okay, and we will keep on repeating this practice unless and until the sum of square of the digits of the number is equal to 1. So here it says repeat the process until the number is equal to 1, correct? So first of all we have to think about the terminating condition. In the happy case, the terminating condition would be 1. So in this example, 19, 1 square plus 9 square equal to 82, 8 square plus 9, 2 square equal to 68, 6 square plus 8 square equal to 100. So again, 1 square plus 0 will give us 1. So 1 would be the terminating condition. So this is for happy flow. What would be the case in case of a negative flow? So in negative flow, you can we can do a little bit brainstorming and figure out in case of negative flow, these numbers will start looping in, correct? So once we encounter the number which we have already processed in the past, we can say that okay, we are going into a loop and now we have to stop the processing. So a simple approach which comes to our mind is we can take a simple collection like an array list or a set simply, and once we calculate the square of the numbers we can maintain all these in a set like 1 square plus 9 square equal to 82. We can add 82, also we can add 19 into the set. We can initially start with 19, we calculate the sum of the square of its digits which is 82, add 82 in the set, again calculate the sum of the digits 68, add 68 into the set and keep on adding. And before adding any number we will just cross check whether that element exists in the set. In case it exists, we will break the loop and return false, and in case one is encountered before that, we will return true. So this is one of the approach, but in this case also we would be using an extra memory, the hash set which we would be maintaining. So another optimized solution of this approach could be to maintain to go to the process to the solution of fast pointer and the slow pointer, which we generally use to solve problem like circular linked list or detect loop in a circular linked list or a normal linked list. So I have already written down the solution. Let us discuss it. So this is the same question. So what we can do, let me quickly go back to the question. What we can do, we can maintain two sum. So one sum will be one step like 82, 68, and we can maintain another sum of digits which would be two step ahead of this, correct? And in case the fast and the slow one meets, we can simply say that the condition is not met and the number is not a happy number. Okay, let me show you the implementation. So here I have taken two integers slow and fast, initialized it with the number which I am receiving in input. So slow, this will be my slow pointer, this will be my fast pointer. The slow gets sum of digits, and I'm inside that initially I've initialized it with the input n, and I'm passing the number to the function. Inside this function I'm doing nothing special, just breaking down the digits as you can see and calculating its sum. So this is a very standard way of breaking down the digits. You iterate the number unless and until it is greater than 0. You take out the last number, square it, add it to a temporary variable, again reduce or remove the last digit, and keep on repeating this process unless the whole number is traversed, right? So this is a very standard approach. I'll again go back. So slow will initially calculate the sum of the digits in one step. Fast, here what I am doing, I'm inside the get sum of digits, I'm again passing get sum of digits fast. So here I'm doing the calculation one step ahead. So fast is going in twice the pace of slow, and I am doing this in a loop unless and until slow and fast meets, right? So even if fast becomes 1, we will get out of this loop. Okay, and finally we'll just simply check whether the slow pointer gave us 1 or something else. Okay, so let me quickly check this solution. So this is the same solution which I was showing you earlier. Let me run it and check if it works. Yes, it is working correctly. Let me submit it. Yes, the solution got accepted. So this is pretty simple approach, a little bit out of the box approach, but nice. Thank you.